Hi guys. All right, I'm going to try to explain today's lesson for you. Let me just present it quick, and then I will actually maybe do a couple of the homework practice problems with you guys as well. Let's start with muting that. All right. So we're going to change dimensions. If the dimensions of a polygon are multiplied by x, meaning the number that they give you or the number that you need to find out, then the perimeter of the polygon changes by a factor of x, which means it's the same thing. So the dimensions of figure A are multiplied by 2. So meaning the outer numbers, the numbers you see. If I do 3 times 2 from figure A right here, 3 times 2, I would get 6. All right, I doubled that side. 3 times 2 is 6, and 2 times 2 is 4. That's how I'm getting figure B, because the problem is actually telling me that I'm multiplying by 2. Sorry. So they want you then to find the perimeter of figure A, which would be multiplied by 2. So perimeter is the outer part. So 3 plus 3 is 6. 6 plus 2 is 8. So that's the perimeter of figure A. But if I just do 8 times 2, I can easily get the perimeter of figure B, which would be 16. This thing is so stupid. Can I do this? All right, I don't know if that helps. That helps a little bit. Okay, cool. Now I have my little tools and stuff. All right. Suppose the side lengths of the parallelogram at the right are tripled. So tripled, that word means times 3. What effect would this have on the perimeter? Justify your answer. So it would make the perimeter 3 times as large, or 3 times greater. The dimensions are 3 times greater. So if you look here, this side is 3. If I'm asking you to triple it, what's 3 times 3? 9. This side is 4. So what's 4 times 3? 12. And you're going to click through. So the original perimeter would be, the original perimeter would be 2 times 4 plus 2 times 3, which is 14. The reason why they're multiplying by 2 is because if this side is 4, this side also has to be 4. You can't just do perimeter with 2 sides of a 4-sided figure. You need to do it with all 4 sides. So you either can write in the 4 here, which I will try to do for you. This side is 4. That side is 3. So instead of doing 4 plus 4 plus 3 plus 3, they're simplifying that equation by doing 2 times 4 plus 2 times 3, which equals 14. Now, if you're tripling the perimeter, you would simply triple 14, which is multiply it by 3. Sorry. Let's see. All right. So the new perimeter is 2 times the 9. So again, they're only filling in one side, but if that side's 9, this side would be 9. Sorry, guys, writing with a mouse is hard. And if this side is 12, then this side has to be 12. All right. So they simplify that by just doing 2 times the 12 to represent the 2 sides of the figure, plus 2 times the 9 is 42. That's the new perimeter. But if you do 14 times 3, you do get 42. And they're showing you that if I divide my new perimeter by my old perimeter, I get 3 as a value, which is the tripled thing. So the perimeter is 3 times the perimeter of the original figure. That's all. All right, let me erase these. Suppose the side lengths of the pentagon below are multiplied by a quarter. Now, multiplying by a quarter is the same as dividing by 4, guys. So if we divide each side by 4, what effect would that have on the perimeter? Right now, the perimeter is 8 plus 8 plus 8 plus 8 plus 8, or you can simply just do 8 times 5, which is 40 inches, because perimeter is not squared, only area is squared. Now they're asking you to take 1/4 of means multiply the perimeter, which is currently 40, or 40 divided by 4, which is just 10 inches. So if I went ahead and divided each of these sides by 4, that means I would make a new figure. Sorry, my drawing's not the greatest. That would give me sides of 2. And since there are 5 sides of 2, 5 times 2 is 10. So your answer would be 10. Let me again erase all this, sorry, so you can read the book's explanation for it. So pretty much everything I showed you over there, and 10 would be your final answer. And that was all the math. You can always rewind this video and pause it to look at that, because unfortunately I have to erase to go to the next slide so it doesn't look confusing. Okay. Oops, sorry. Don't really know what's happening now. I want to turn this off. Okay. So changing dimensions of area now. Sorry, the slide got a little messed up. If the dimensions of a polygon are multiplied by x, when the area of the polygon changes by x times x. So again, look here. Figure A is 5. How do I get from 5 to 10? I multiplied this by 2. So figure B is 2 times larger than figure A. And area, now we're talking about area. Area is length times width. So you're just going to do 8 times 10 to get 80, and 5 times 4 to get 20 for the area. But now we get to combine the lessons from last week into the lesson from this week, which is finding the area of a triangle in order to change the dimensions. So the side lengths of the triangle at the right are multiplied by 5. So it's literally telling you you're multiplying this side by 5 and this side by 5. So again, I'm going to get my little drawing tool and let me try to draw a triangle for you guys. And I'm going to multiply this by 5. 5 times 2 is 10. So the new length of this side is 10. 5 times 1 is 5. So the length of this side is 5. And remember, we always need our units, so 5 centimeters. And we can even draw our right angle because this is a right triangle. What effect would this have on the area? Well, the area would be 5 times larger. It's literally telling you in the area, in the question. I'm sorry, not 5 times larger. 5 times the area. So 5 times this. So it's 25 times larger. So whatever the number is here, you're going to like square it. Sorry to confuse you there. 1 times 2 is 2. So the area of this little triangle here is 2 square centimeters, right? And this area would be 5 times 10, which equals 50 square centimeters. And now if they're looking for the effect on the areas, how do I get from 2 to 50? Well, I multiply by 25. So the effect would be 25 times larger is the area. So again, I have to there's all the same things. I will delete all this. Can I just, there we go. That's even better. See, we're all learning together here. So there's the bigger Triangle, they just follow the rule of multiplying each side by 5, like I showed you before. And the areas are here. All right, 1/2 the base times the height. The only thing I didn't show you guys was divide by 2, but it still justifies the 25 times the amount. So it's not too big of a deal, but there you go. So the area is 5 squared or 25 times the original figure. So if we go back to this slide right here, that's what this is saying right here. Whoops. All right, x times x is really just x squared. That's where they're getting this information from. This is very confusing, guys. I'm sorry. But it's in your book. This whole presentation's in your book. It starts on page 698, and it gives the explanations. It gives the figures, the exact same things you're seeing here, minus these kinds of examples. But again, you still need those formula sheets that you should have set up or wrote down for yourself from my other presentations that I did earlier. If not, just go back in the book and look them up. You need to know the area of a triangle, which I clearly messed up on the other slide because look, we're all learning and we're all tired. Let's do this one. Parallelogram has the height of 3 meters. Now, it's beneficial for these types of problems to draw it out. And as we know, it's not easy to draw on a computer. All right, there's my lovely parallelogram. And the height is 3 meters. So here's my lovely height. That's going to be 3 and a base of 8. So there's your 8 meters. Okay, I'm running out of room here. Try to fit that in. That's supposed to be an M. Suppose the base and height are multiplied by 3. So now we're going to do a bigger parallelogram here. And sorry, the 8 we're going to multiply by 3. So 8 times 3 is 24 here. And here's our height. And then 3 times 3 is 9. So now we have to find the area. An area of a parallelogram is just base times height. So this is 8 times 3. So this area would be 24 square meters. And this would be 9 times 24, which is, sorry, that's my daughter, 216 square meters would be that. So now if you're looking for the effect between the areas, you're going to take your 216 and you're going to divide it by 24. And your answer is going to be 9. So the effect is 9 times as greater, larger. Simply take what they're telling you here and square it. 3 squared is 3 times 3, which is 9 times. But unfortunately, you have to show all this work in order to provide us with what we're looking for. So there you go. The area is 3 squared or 9 times greater. The area of the original figure is 24 square meters, as I showed you, and the new one is 216 square meters. A stop sign is in the shape of a regular octagon. So that means that all the sides are equal. Sign A shown at the right. So here's your figure that they're talking about. Oops. Okay, sign A has an area of 309, and they want to know the area of sign B. So we're going to flip my page here. Sorry, I'm just reading. So what information is given to us in the diagram? the side length of side A is 8 inches and the side length of side B is 12 inches. So we need to find the area of side B. The scale factor is going from A to B is 1.5. So to find the scale factor, you're going to just simply divide 12 by 8. And again, you guys are allowed to use calculators. So 12 divided by 8, that's where I'm getting my 1.5 from. So in order to figure out the area of side B, you have to do 1.5 squared, because the area is measured in square units. So you're going to do 8 here times 1.5. That's how you got 12. So then if you just do, now remember I told you this is the number that you multiplied by, right? That's how we did like the other ones in the previous examples. So you had to square this number in order to get your new area. So now you're going to do 309, which they provide to you up here, right? Times this 1.5 squared, or 1.5 squared. So in your calculators, do 1.5 times 1.5. You're going to see that 309 times 2.25. This 2.25 is just 1.5 squared. And you're going to get your answer of 695.25 square inches. Sorry. Oh, it's so sloppy. That's how you went about that whole thing there. So first step, divide, because you want to figure out what you multiplied 8 by to get to 12, because that's your factor, that's your scale factor. Then you just square that answer and then multiply it all by the given area. So now I'm going to erase my screen and I'm going to go back and just show pretty much everything we just did in red in neater writing. All right, again, step 1, figure out the scale factor, which is 12 divided by 8. That's where we got the 1.5. Then you're going to square it, times it by itself in order to get your new area, because that's just the formula that they provided to us in the beginning. So now let's try this one. Are we lost? Can we do this one by ourselves? The area of the small trapezoid shown is 6 square millimeters. What is the area of the second trapezoid? So again, we have to find the difference between these two. So 10 divided by 2 is, get my pen tool again. 10 divided by 2 is going to give us our scale factor of 5. Okay, then you're going to square this. So that's step 1. Step 2, take your given area of 6, multiply it by the square, 5 squared. So step 3 is 6 times 25. I'm sure I could figure that out in my head, but again, we're all going to be lazy. So that is going to be 150 square millimeters would be your answer. Again, step 1, divide your two given sides by each other. That answer is your scale factor. That's what I multiplied 2 by to get 10. And I know you could do that. You don't have to actually divide, but your safest bet is just to divide them, because as you saw in the last example, we got a decimal and we don't want to mess it up. they're not always going to go in so nicely like 2 times 5. So this means that this figure is 5 times this figure, the side length. Once you get the answer, the scale factor, you want to square it. Just the rule. This is how it's going to go. 6, the original area, times the square of 5. 6 times 25 is 150 millimeters squared, or square millimeters. So that is the area of this figure. So we didn't even have to do the 1/2 the height times base 1 plus base 2, because they didn't give us base 2 here. They didn't give us base 2 here. They just gave us the area that we had to work with. But it is still doable. All right. That is the lesson. I'm not even going to do this part with you, but what we're going to do, is our homework practice. All right, let's see. How many questions do we have here? 5. All right, I'm going to do 1 and 2 with you guys, and I'm going to leave 3 and 4 to do. I'll even help you out with number 5. So let's do number 1. Describe the change in perimeter from A to B. Okay. So A, 5 to 10, 6 to 12, right? So it's times 2. 2 times greater. So figure B is 2 times greater than figure A, but they want us to provide them with the actual perimeter. So you can do this by figure A. I'm going to write here. You're going to do 6 times 2 plus, I'm sorry, I lied. Sorry. You're going to do 5 plus 5 plus 6 plus 12, because it's a trapezoid. So that's 18, and 10 is 28 is this perimeter, 28 inches. And figure B is 10 plus 10 plus 12 plus 24, which is 56. And if you look at the difference over here, if I just did 28 times 2, I still get 56. So the answer to number 1, the change of perimeter is 2 times greater. 2 times greater. For number 2, describe the change in area from figure A to figure B. So now you need to do the area of the trapezoid. Now this, you actually have to do the area, which is that area equals 1/2 the height times base 1 plus base 2. I'm not going to have a lot of room to write here. So for figure A, it's 1/2 of 4, right? 4 is the height, so it's 1/2 of 4 times 6 plus 12, which is 18. So 1/2 of 4 is 2. 18 times 2 is 36 square inches. I'm not going to show all the math here. I'll talk about it. Figure B is now going to be 4 times that amount, because you take the scale factor of the 2 here and you square it. Remember, 2 times 2, which is 4. So literally you can just do 36 times 4, which is 4, 24, 2, 12, 144. Am I doing that right? Square inches. Boop. And if we actually did the math here, it would be 1/2 of 8 times 12 plus 24. And 12 plus 24 is 36 times 4, which is 144. But this is the kind of work that you would show. All right. You don't have to do, this is figure B. I know I went into 3, but this is all number 2, right? This is all number 2. Then you're going to do the same thing for 3 and 4, only you're doing the area of a triangle and not the area of the trapezoid. Okay, you just have to look at the figure. I'm just going to clear this out. All right. And for 5, I'm going to figure out, I may just start a different video because this one's long enough. So let me post this and hopefully this helps you guys. And then I can try to do 5 with a little bit more room because the room that they supplied me with here, I don't think I'm going to be able to squeeze it in like I did for the other ones.